Welcome to Learn with BMW Swale. In this session, we moved on part 4 of Introduction to Object-Oriented Programming. In this part, we focus on encapsulation and properties. Focus on encapsulation and properties. Then we'll give some practical example and we'll conclude this session. Sure. So it's important to understand by the words of encapsulation and properties. In the early video, we introduced what encapsulation was, and the new thing for me is what we are calling properties. Encapsulation, think of it as a capsule. Yeah, you know what a capsule is. So encapsulation is a key concept in object-oriented programming. That's what we defined as the way of hiding attribute and method inside object. So we said it's a mechanism or a strategy of hiding attribute or method inside an object. That's the whole thing about encapsulation. Why? We don't want to expose everything about our classes. We are putting strict access to certain methods. That's what encapsulation tries to deliver. That is, for a customer, we created a customer class. You remember this part? We created a customer class. Then we emphasize that the first part is made of attributes, right? Then the second part of the UML diagram is made of method. That's what we said. There we come in method, and there we put attribute. So the issue comes in when we create an instance of this customer. When we create an instance, that means we create a customer number 1 is equal to customer, then we put a constructor. This customer instance, so this object that has been created in a program, it is able to access and modify the values in attribute. You know how we call everything? We just say customer number 1 dot name. So this instance can change the state of this variable. We can assign the new name to Chanda, right? When the customer was joined. So we don't want such kind of access. That means we are not allowing attributes to be accessed by outside entities, and we only want to allow those attributes to be accessed by method or modified by the method inside its class or inherited variables. That's what encapsulation is. So it's just a simple way of doing it. Nothing will be complicated. The overall thing is just to hide so that these attributes shall never be accessed in this way, but only method shall have access or modification, manipulation to attribute. Yeah, that's encapsulation. The good part about this is that encapsulation works hand in hand with the properties. This is a new thing that we are about to learn in this session. Properties. Yeah. So a property is just a tool in Python used to safely view and validate the hidden data. It's used to safely view, that is get, and validate, that is set, the hidden data, right? Yeah. So that is the concept of properties. We shall use this annotation or decorator to make such kind of access. So we are saying that it is easily used to view, the safe way of viewing data or accessing data that has been hidden. You know, the way to hide data, it is through encapsulation. Encapsulation, right? The one we just defined. So now we are providing a mechanism by annotating a method by saying property, so that we can easily view the hidden information or hidden attribute and method of a specific class. That is property. I hope you now understand the relationship between property and encapsulation. Encapsulation. You really understand this part. For the record, in this session, we are on encapsulation and properties. So let's answer this exercise. We demonstrate what we are really talking of. So the first part of this session, we are going to compute this part. We have been told to create a person class with private attributes. Whenever you have private attributes, we are talking of encapsulation. Those attributes shall be name and age. Use properties to provide controlled access. It's the one from explaining how properties are used to safely view the getters and setters of these attributes. That is a controlled access. Name should be string and at least 2 characters. So this is just all about the validation, right? They are just giving name rules to how the attribute should contain its information. And the second part, they are saying age should be between 0 and 150. They are just saying 0 and 150, and there is no age of 0. Yeah, there might be. So we are also going to make age read only after initialization. Yeah, there's no way of changing age, so we are going to make it read only. So read only is a property that makes sure you are safe reviewing the data, right? Yeah. So actually, let's do this in programming, and we see what we are actually talking of in terms of encapsulation and the properties. All right. Okay. I've created. They said we create a person class with private attribute, name, age, and use properties to provide controlled access. So that's what we are going to do here. And you know, whenever we're creating a class, you give it a class name. Class name that is a person. Then we move on to a constructor. This is a constructor. We say name and age. From there, self.name. So that's where the core part of encapsulation comes in. So how do we do that about encapsulation? For us to perform the function of encapsulation, we just have to put this underscore to every name variable. So whenever I put this name variable, I'm giving a controlled access to every programmer or anyone who is able to view this code, that this underscore simply specifies that we are doing the hiding mechanism. Okay. From there, we are also going to validate the age before we do like self.age is equal to age. So before we do this, we have to validate it. So I prefer this age should be below the condition of validation. If not 0 less or equal to, they said the age should be 0, between 0 and 150. Okay. Then if not age is if not age that we are put, if it's not in this condition, in this range, then we are going to flag an error to the user. So we are just going to use the error handling mechanism by saying value error. These are fundamentals of Python, so they shouldn't be the thing to talk of in this session. We believe that we already know this kind of thing. All we are doing is combining them together to perform what is asked of us. So age must be between 0 and 150. That's a flag we're going to give to the user. Or else self age is equal to age. Okay. So as we are talking, we have performed encapsulation from here. We're making sure that the access of this method shall never be access to anything outside this class. Okay. Let's try to implement another property or another method which will be returning the value of the name. right? Self. This is an instance method which will return so dot name. It will return the name. So this has there's nothing new about this, but the only new thing is the controlled access that we are giving to this property. Yeah, this is a keyword that we'll be using to provide the safe way of viewing this variable. And we are you are going to see the difference to how we'll be calling this method. It will look like more like a variable, right? Yeah. So we are this is a getter, right? It is just returning. We introduce the forms of methods called getters and setters. Yeah. And for now, maybe I can just explain. A getter is a method. A getter is a method that can only access, right? That can only access but cannot modify attributes. Like this one is only accessing this variable, but it's not providing anything or anything to change about this variable. It's just returning. Okay. So we're going to make now a setter that modify a variable. So there's this new method that we are going to see a name setter. Okay. Def name self name. Okay. After this is just a method which will be setting the name variable. We understand we have a constructor there that is setting the name, but sometime we won't be based on that name. We may have to change the name in some other time. Changing the name can only be accessed through a method called a setter in this guide. So even if we are trying to modify the name, we have to put a condition, because in a question they said the name should be a string at least 2 characters. So we have to do that, at least 2 characters, right? So name, or just say okay name, then the length of that name should be uh, if that length of that the name is less than 2, we're going to raise an error value error, and we will comment that name must be at least 2 characters, something like that. Or else then set name self dot name, which is a private property, is equal to name. This name shall be received in there. Okay, hope we are doing the right thing from A. What else did they ask? Also to create an age property. So this property is just returning. So we will provide the safe way of returning this getter method called the age. So this age shall return self private, which is encapsulated age. From there, we shall provide another thing, make age read only after initialization. And we are going to make that this is the age or has been initialized here. So if they say make age lead only, so we are only leading, we are not setting. This is doing some manipulation, setting the name, but it was initialized there, but again here is doing some modification. So if they say lead only, it just adds have to retain the variable. From there, would it be possible to determine if the age that has been entered, if the person is an adult or not? Yeah, it's important to do that. So let's implement this method called is adult. So depending on the age that was received, this method will be able to tell if the age was an adult. Return self dot age which is private variable. If it is greater or equal to 18, then it is an adult. Perhaps here we can put uh, this method called boolean. Boo, say keyword to return true or false. Okay, it's a quick function that return true or false. This is just showing to return the data type of whether false or true depends on the age, right? So I think we are done from A. We have done some encapsulation, and we have also done some property for controlled access. Let's just observe the outcome of what we have done and what that controlled access we are talking of is going to be. So shall we create an object maybe called Aris? Not necessarily Aris. Don't like girls. So we just say John. John is equal to person, or this one. I like doing this as an uppercase. The class name should start with a capital letter so that we don't confuse ourselves between the file name and the what. Yeah. So this one should receive a name called John Warrior. This is an object, and by the age of 25. Okay. Yeah. So this is where the interesting part comes in. So I'll just say using datas and computed property. Okay. We shall put a print function here. We want just to start accessing those variables. So name is equal to John. Like, this is not making sense. Just say student one. Yeah, student number one. So we just say student number one dot. We are saying how to get the method. So student number one to the previous classes, in terms of accessing these instance variables, we were putting the headers. We were like, for me to access this value, maybe I want to determine the age. So student dot age. Then I have to put this to be certain that it's a function I'm calling. But whenever I put a property there, the way I'll be calling those function methods inside the class, when I've decorated it as a property, it will be called just like a variable, student age. You see, just like a variable, as if you're calling. So you may not know what you're doing, as if you're calling this age or as if you're calling this age, because this is a method and this is an attribute, an instance attribute. So here, and outside the programmer A wants to know what you are doing, and that is a core part of our system, is to hide, to make something hidden, so that you don't know if you are accessing a method or you are accessing an attribute. So that's just like that. Behind the Python is going to know what is being called. Is it age as a method or age as an attribute? Yeah. So that's a core part of this discussion. Okay. So in the first place, we are calling name. We have to print as well if age student1 dot age, just like that. So we don't know if we are calling age or what. Just let me move away from this one so that you get to understand what we're talking of. I'm going to temperature converter and remember we called this method Celsius to Fahrenheit and we pass argument as 37, right? Yes, but there we pass argument as 37, but we should have just done like that. Then we just is equal to 37 if this was a property. But now since it's a property, so we have to provide an hidden mechanism so that we don't show if Celsius to Fahrenheit is a method or an attribute. That's a core part of encapsulation and the property, this part. Sure. We move on to the statement that is testing if they are adult or not. Then we shall say student is adult. Maybe shall be a question. Then it will turn true or false. So student dot is adult. Yeah, even is adult. I hope you have seen some difference. We said that when you're calling methods there, we have to put this header, right? Yeah, but we're not doing this because of property. Okay. We move on to the next part where we'll try to update the function code name when we add this method the setter. So let's call it because it has to receive an argument in there, right? Yeah, it has to receive an argument from there. Print. We are trying to update this variable. Maybe we just comment updating attributes. Say free. Because I have to show this so that you understand. So now to update an attribute safely, student dot we want to update this name so that it's update that variable. So we call this method, right? Yeah. Normally we used to say name, then we want to pass an argument. Now Alice. We shall not do that. Encapsulation and data item is there to confuse some sort of hackers or people who do not understand the program. So that's a core part. So that not everyone can be able to manipulate. So instead of putting an header, it will be just like an assignment statement. And we shall say, we also don't like remains. So the name was John, and now shall be given to BMW. Shall be given to Swale. Okay. From there, we also have to validate the name because we had put something like that. If name was less than 2 characters, it has to bring name must be at least 2 characters. So let's see how we can come out that way. So print this validation attribute. Okay. So now, since we had put an L handler, that is value L handler, so the program is going to crash if I just say student dot name is equal to p. This is less than 1 character, right? And the program is going to crash. So we have to provide way to handle that kind of error safely. And you know the error handlers, something like that. So student C is equal to p. Then you will see an error from there. Except attribute error as an error. This shouldn't be a new thing to discuss because this is part of fundamentals of Python. So I'm just trying to catch an error. Code expected to be more than 2 characters. Okay, from there we can move out. So we can even do this to age, right? Yeah, we can even do this to age, because we also have to validate the age. Where is it? If not age, so it has to rise the value error. So maybe age 151 or -1, it has to rise an error from there. So even from age, we have to put it this way. We have to put it that way. Okay, try. This is second student. Students 2 is equal to person. Then it'll be like warrior, comma, -3. Because people are so reckless, they can put anything. So you being a programmer, you have to be validating such kind of situations. So this is a value error as A, or we can just complete it as error. Then we print. This is just a method of telling them an error occurred during data entry. Try again. From there, we try to test our program. If it is running successfully, then we conclude that we have demonstrated encapsulation and property. Okay, we compile this program and we have called the main method. Okay. Python person.py, except some errors to arise and some output. Okay, we have successfully executed what we wanted here, and I'll explain this part. It's not an issue. So the first part is how we are accessing the variables. Name.name, student.name. We called that method and it has to print John Boyer. Okay. Age 25, it has brought is an adult, a student, and adult. True, because it was greater than that. This was just a simple function that we used during the implementation, right? Then we continue to this statement, updating attribute safely. Student.name is Swali. Okay. We have updated attributes, so we can print now. I didn't print that part, so we can say student1 dot name. So it must bring the new name. Dot name must bring the new name from A, because we have updated it, so it has to bring swag. But look, I'm just accessing more like a same variable. I'm doing like at the same time I can print it, at the same time I can assign it. These are the works of properties. So let me learn this program again. Okay, printf new name. Okay, I miss the colon from there. Okay, so let's see this output. Don't worry about that. Our new name is what? Swali. So we came to this first testing validation attribute safely. So we tried to put this name to be P, then it brought student name error. So once it brings this kind of error, then it won't update this name from A where it was being validated. It won't update A. And the reason why for this kind of error, it is being lies from the class name, because you have to put name must be at least 2 characters. That's the error which has been brought. And mind you, we didn't put any uh, error exception book. That's how it is raising the error directly. So if here we had put anything like it, try and accept the error, it won't bring anything like that. Sure. So we have demonstrated this kind of variables about encapsulation and the properties. So in the next video, we'll come to look at computing and designing rectangle class with private attributes, width and height. Design a rectangle class, private attribute, width and height. Create properties for width and height with validation. Area computed property, read only. Perimeter computed property, read only. Is square boolean, read only. By the way, this part we already made the class when we are introducing about objects and classes. So I believe in the very first video should be part 2. We had created this class. So in this guide, we are just going to modify this class by putting in the aspect of encapsulation and the properties, right? Yeah. So let's visit this file, and then we fulfill the function of width and height being properties. Okay. Okay, I believe we created this rectangle class. Yeah, we created this part and we demonstrated some other aspects. So in A, we are just going to modify. So I'll try to comment this code. Okay, I'll try to comment this code so that we can all be able to read. Computed for design a rectangle class of which we already designed with private attribute width and height. Get properties for width and height with validation. So we follow the first part, private attribute, width and height, and we know how to fulfill that part. So in the initializer constructor, we just put that part to be private. And the next part, they said, create properties, width and height with validation. So if they say create properties, width and height with validation, whenever we see properties is where we use getters and setters for safe view. So in this class, we never created anything else to do with getters and setters. We only relied on the constructor attribute which we are receiving. So from here, we want to create only variables to validate width and height. Okay, shall we do so? The first part, we shall annotate it by saying what? Property. Property. So then we create a getter for width. Shall we say define width self return width, right? From there, we can now, they said validation. So we here is the read only property, and we want also to give it a setter that will is going to make validation. The same with this, we say with this self with this, okay, which will be received outside. Then we make some validation. So what about with it? It's an integer. Okay, so we should just say the which with it shouldn't be less than 0, right? Or greater than 100 meters. Okay, that is the validation we're going to implement for now. And before we do that, since this is a setter, we shall annotate it because it's already having the property. So we just have to annotate it by saying with this dot setter. Okay, then we put some condition there. If with this is instance, Okay, we're going to validate this widget to determine, because a user can input what a string. So if is instance, if widget is instance, which is widget, then we shall lies an error. Lies error, type error, type error. Then we say widget must be a number. Okay, from there, if length of widget is less than or equal to 0, if length of an widget is less than or equal to 0, also lies value error. These are just exception value error, by saying name must be greater than 0, which is widget must be greater than 0. Then if anything is okay, then we're going to assign or to set the value of widget by private property as private variable to be equal to widget, right? Yeah. This widget is the one that will be received outside of this class. Okay, we have done something A, so we are remaining for height. Just the same thing we are doing E. Okay, we are doing for height. Height setter, then we're going to receive height from there. So the same logic of determining the value, height must be a number, or also height must be greater than 0. If anything else, then we will assign length to width. Actually, it's not height, it is length. It is length, and we will try to determine if that length is an instance. An instance, like a string is an instance, that means a string is an object. We can do a lot from them. Then integers, these are primitive data type. Hope you understand from that. Okay, so length is equal to the length that will be received here. Okay, I think we are done from validation of these two variables. Then they are saying area computed property lead only, which is, where is the area? This one. So they leads in computed property. So the most thing we can do here is just to annotate it so that we can safely read it. That's all. That's what they were asking for. Then perimeter computed property lead only. Sure. So even perimeter property shall be lead only. Is square boolean is boolean property. So is boolean property shape type, return rectangle, return shape type. So we're just going to say this boolean, say bool. Then we'll change the logic A. That means we're even going to modify this. Maybe we'll call it is shape square. Then to return if length return. So this is just an implementation logic A that will return self length is equal to width. So If length will be equal to width, then it will return either true or false. That's what they ask in here, Boolean property. Then we are done with this question, and let's try to access these properties in the main program. Okay, and remember we had created two objects. Object one is house room, object two is room rectangle. Okay, so we had to print house room area, house room dot area to get the area. So since now we are working with property, so with some encapsulation, so we no longer need to access the area this way so that to confuse the enemy. So we shall just do like this: house dot room area. Someone will be just see either the function or a variable. Same applies to print from two area to be done that way. House room shape. So house room shape is where we said we have changed to is shape square. Then to confuse the enemy, we shall not put this because it's a computed property. So let's put this thing. Okay. What else do you want to test here? Maybe the setter for width as well. Setter for width. So even shape type for room 2 of changes to is shape square, just like that. From there, we want to do some operation for the setter. Let's try to set this part also to get the width and the height for house room 2. So maybe we just print, just say room 2, which is having the width of 4, it's just return the width of 4. So length is equal to room 2 dot the length. So this is just a variable, a new variable, which is sent to access the method. This is the method. In terms of property, we are there to confuse some people. Okay, even width is equal to room 2 dot width. I'm just showing how to access these variables, and we can print them out. There shall never be an error. So even the setters for room 2, we can set them. Room 2 is equal to length or width is equal to 6. We have changed now the width of this room 2 to be 6, from 4 to be 6. And previously we used to do this, right? To pass an argument. So now since it's a property, we just have to say 6. Then behind Python will know what has been called, and it will be able to compute it from there. So okay, so this method is supposed to be what? This length. Yeah, because we had two of them. I just copied and pasted, then I changed the things in there. All right, from here we have done something. So room 2 shape type is shape square, is just to bring 2 true because it's 4 4. Now since we have changed the width to be 6, it has to bring false. So let me copy this and paste it here to see what's going to be. New shape type room 2 dot square. Since we have changed the width to be 6 from 4, it has to bring some different information. All right, we have tested the properties and encapsulation. Now let's try to run this program and see the outcome. All right, so before I learn this program, we have to double check some sort of errors and corrections that I want to make. Okay, yeah. So when we were creating this property, we had to return the private attribute that we are putting. So self width, and also when you are implementing a setter, you have to make sure that you have this property. This property, there must be an attribute which is existing as an attribute before you make a setter, right? Yeah. And this method and instance requires two arguments because we're trying to determine if it is a string and we don't want anything else to do with string. So it requires two arguments, width and scr, representing a string characters. Okay, so even in property, for length, we had to make this as a lead only. Then this part, we are emphasizing that it's a set that we are making, and the length attribute is coming from these variables, and it is the same thing that we have to test of. So we have also to put a scr to determine if it is a string. Okay, from there now let's try to run this program and see the output. This is in Python rectangle.py. Okay, and we have such situation. Okay, we have what we expected. So house room rectangle, an object which was created, and we try to print house room.area based on those values. 6 times 3 must be 18. Okay, so the second, the line 56 statement, we created room 2 object and we passed 4 and 4 as argument in there. Then we had to print out the area. So as you can see, it is 16. Okay, in line 58, we try to determine the house shape by saying dot is shape square, and it has returned false. As you can see, 6 and 3, they can make a square shaped angles. The second part we had to change. Here we are just accessing the variables length dot room number 2 dot length and room number an instance variable dot width. We are just accessing, these are the leads on objects. If we wanted, we would have also printed them here directly, but we are just showing how to read them, so you can print this variable. So in the same situation, we had to call this method. As I explained, we must have done something like that because of the property decorator. It seems like we are just visiting a variable, but we are passing it an argument in form of an assignment. So room.width 4, then it has changed room shape 4, but it is still 4a, so nothing will change there. Let's try to put it 6 so that it returns false, because 6 and 4, it can't return a new shape type to be square. Okay, let's try that. Okay, false, new shape type here. New shape type, an instance object dot is shape square, trying to determine if it is that way. Now it has returned false. This was based on our logic here. All right, otherwise, thank you for staying with us up to this end in this video. In the next session, we're going to look at inheritance. That we are going to focus on. Stay ahead. Cheers. See you in the next video.